Good morning, everyone. Here is the power section of a Lenze drive EVS9300ES. Now these are pretty much standard for all of the 9300 series drives. So what we have over here is the three-phase bridge. And that comes across this flexible ribbon over to a dual choke. These four relays right here, these are your pre-charge relays. And in between these four relays are hybrid modules, and they're resistive hybrid modules. They serve two functions. One is to pre-charge the bus capacitors, and the other is for the feed-forward resistor of the switch mode power supply, UC3844B. That's on the back side of this board. Now, I've got this all drawn out, so I'll show you my drawings here in a little bit. But also right down here are two quarter-watt resistors, and they are also in the feed-forward of the hybrid module resistors. This capacitor right here, VCC to ground of the UC3844. So we have a DC bus voltage, pre-charge relays, resistors. Now, let's go to the other side and we'll look at where the UC3844B is. It's this IC right here. That is your switch mode power supply IC. That right there. Let's get a little bit closer to that circuit. So pin 7 is VN of the UC3844. Pin 5 is ground. Usually pin 5 will be connected to DC bus ground. So pin 7 comes underneath the board and over to this capacitor, surface mount capacitor, and that capacitor is connected to pin 7 and pin 5. Now, pin 5 comes over here, and this is the positive side of a 22 microfarad 25 volt capacitor. This side right here is the ground side. It's connected to pin 5, and the positive side of that capacitor is connected to pin 7. So now we come over to this resistor right here, and that resistor is a 7.5 kilo ohm resistor. And the other side of the capacitor goes to a Zener diode, marking code Y9. And its anode, so you have the 7.5 kilo ohm resistor goes to the cathode. The anode goes to bus ground. On the output side and the cathode side, output of the resistor and cathode side, we come down here and we go to those quarter watt resistors. And they're in series. And now the two quarter watt resistors come over to these hybrid modules. Now it gets a little bit confusing as to, here's your back side of the hybrid modules right here. And that resistor, the output of those two quarter watt resistors, go to this point right here of the hybrid module. Let me get my pencil and I'll be able to point it out a little bit better. That point right there on the bottom side of the board, those two resistors come over here. Now we're going to get to the paperwork. The fun part, right? Okay. Give me a little bit to drag my drawings over. Here's the UC3844B. Here's pin 7, and that's VCC in. Here's pin 5, and that's ground. Here's the surface mount capacitor, and here's the electrolytic capacitor, the 22 microfarad at 50 volt. Now this point right here, I'm not sure where it runs off to. I wasn't worried about that. I wanted to know how this IC got powered up. So we come back to the 7.5 kilo ohm resistor. Here's our Zener diode, Y9, it's 24 volt according to that marking code. Here's those 2 quarter watt resistor, 24.39 kilo ohms, 24.39 kilo ohms. And pin A right here runs off to another page. Let's bring that other page in. Here are those hybrid modules. Now this, one of the functions of the hybrid module, let me get a hybrid module in the picture right here. This is what they look like. This is one I've taken off the board. But one of the functions of the hybrid module, besides pre-charging those bus capacitors, is to apply the voltage to the switch mode power supply IC. Now 3 of the hybrid modules are in parallel. Then here we branch off to the 4th hybrid module, and that goes to point A. Each of the hybrid module resistors are 70 kilo ohms. There's point A again. Now let's look at the pre-charge function of those hybrid modules. Right here, this is the P and N terminals of the 3-phase bridge rectifier circuit. The P terminal comes in here through that inductor, the dual inductor. Here's our pre-charge hybrid module on the positive side. It's hybrid 300, hybrid 301, and they pre-charge these 8 capacitors. Now K300 and K301 relays, when the bus capacitors are fully charged, they will close and bypass these hybrid modules up here in the positive side. Now on the negative side, you don't see this very often, but they pre-charge both the positive side and the negative side. So you would have current flow through the positive side, the bus capacitors, and through the hybrid modules on the negative side. And again, when the capacitor is charged, these relays down here, K302 and K303, will energize. And they all energize at the same time. I'll show you the circuit that energizes, the coil circuit that energizes these relays. But down here, hybrid 302 and hybrid 303, they're in parallel. And this is the DC bus and bus ground circuit for the IGBT. Now let's look at the coils of these relays. From our drawing here, we can see that the 4 pre-charged relays are in parallel. They will turn on, the 4 relays will turn on at the same time. Let me change this letter. Let's make that C, because we already had an A. I'm going to make that C, so we don't get confused with who's who. Now we're going to look at the circuit that energizes these relays right here. Okay, we have to change A to a C, because the C was the connection to the UC3844. And what happened was, I made this circuit, I drew this circuit out years ago, and I just recently drew the connection to pin 7 of the UC3844s. I forgot that this circuit had an A already, so now we're straight. Okay, here we have an optocoupler, and on there would be a transistor right here. So here on pin 4 with the 10K pull up, we have 27.41 volts DC, and that goes to the one side of the coil on B. Now to turn on the relays, we have this driver transistor right here connected to the emitter of the transistor. Let me draw that in there. See if I can get this drawn in here. There's our NPN output. And that drives into the base of this surface mount transistor right here with a marking code of 6B. And that takes the other side of the coil to ground. So this is high by 27 volts, and we take C to ground, and that energizes all 4 relays. The input side of the optocoupler, we have a 1.2 kilo ohm resistor going to the anode of the LED inside that optocoupler. And that goes to pin 17. And I measured that, pin 17, at 15.59 volts DC. So this side is always powered high. We pull pin 34 low on the logic side. It goes to the CPU board through that state connector X50. We pull pin 34 low, and photons are emitted from the LED into the base of that photo transistor, causing it to go into saturation and turning on this driver transistor right here, which pulls the coil of the 4 relays. That's the paperwork. Let's look at the pre-charge relays and the feed-forward relay. Turn that around so you can see. Now these 2 outside legs right here, they go to this resistor right here, and we can measure those. A meter in the frame. We can measure those. There's 67.6 kilo ohms. My bad. It's not kilo ohms. Okay, I have to make a correction. These are 70 ohms. Not kilo ohms. Okay, so the pre-charge resistors in the hybrid modules are 70 ohms. I'll show you that. Go on there. Yep, 67.6 ohms. Not kilo ohms. Had a brain fart there for a little bit. Let's go ahead and measure the other resistors that feed forward to the pin 7 of the UC3844. Okay, those are kilo ohms. That's where I got confused. Yes. Okay, so the pre-charge relays are 70 ohms. And the feed forward relay, I got relay on the brain. The pre-charge resistors are 70 ohms, and the feed forward resistors are 70 kilo ohms. I'll get it right. Okay, brain. Engage, brain. Come on. There we go. Now we're corrected. These pre-charge resistors are 70 ohms. And these resistors, I'm gonna be upside down again, ain't I? There we go. 70 ohms. 70 kilo ohms. There we go. Okay, my bad. Okay, I'm gonna try and put this video together tonight so that you can all see that when you get up in the morning. All right, folks, I butchered that one, didn't I? Have you a good day. Have you a good day. And we'll see you when the sun comes up. Can't tell if I'm upside down or if y'all are upside down. Have you a good life, folks. Have you a good life. Try not to work too hard. Bye-bye.